All right. Hi, guys. Today what we're going to be talking about is scientific notation. This is going to continue with our idea of exponents and what we've started to work on in this chapter. So first, I'm going to give you this problem we have right here. It says the planet Jupiter has an average radius of 69,111 kilometers. What is Jupiter's volume? All right, and I provided the volume of a sphere right here, which is volume equals 4/3 times pi times r cubed. Okay, so in order to solve this, we can just type it in. I'm going to use a scientific calculator I already brought up here on the internet. So I'm just going to type out the entire equation here. So I have my 4 divided by 3 times my 69,111, and I'm going to put that to the third power, close my parentheses, and then multiply it by pi, which, as we saw in our thing, is exactly um, what the problem asked me to do, and hit equal sign. Now, what's going on? We have a huge number here. That's astronomical, all right? When scientists are trying to figure out the volumes of planets or things that are really, really, really tiny, they're not gonna fill up a bunch of sheets that look like this, that have numbers that are this big. All right, they're gonna use something called da 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 scientific notation. All right, so scientific notation is basically a shorter way to write a huge number. Okay, so a, the beginning number here, is a number that is always going to be between 1 and 10, and we multiply it by 10 to the nth power. N is going to tell you how many places you move the decimal. All right, so for example, taking this absolutely astronomically huge problem here, all right, I'm going to take this number and I am going to write it in scientific notation, okay? And, so what I can do is I can actually say, all right, well, I have to find the number between 1 and 10. So I actually have to use um, do something like this, all right? So I can write it like this. I'm just going to round because I don't want to sit here forever writing numbers. Multiplied by 10 to the nth power. How many decimal places I had to move? Well, I had to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. All right, so an easier, shorter way of writing that astronomically huge number of Jupiter's volume is to write it in this very simple manner. Okay, I'll show you what I mean now. All right, so right now my decimal place of this big number is right at the end. Okay, I have to move the decimal to form the number between 1 and 10. In this case, we had to move it 9 times to move it between the 3 and the 6 to create the number that's between 1 and 10. Okay, from there, it forms the number 3.647, which in my scientific notation formula would be our A. Since we moved it 9 times, that's going to tell me my exponent. So my answer is 3.647 times 10 to the ninth power. All right. Same with this one. We have to figure out, okay, what is our first number going to be? You said 5.6. You are correct. All right. Multiply that by 10 to a really big number. Remember, my decimal place in this particular case is at the very end. And I'm going to swoop it how many times? All right. And in this case, we swooped it 13 times, and that's where I get the answer, 5.6 times 10 to the 13th power. All right. So what I'd like you to do is do this one for me in your whisk. It's very, very simple. You should be able to do this. Okay. All right. Now, scientific notation isn't just used to write really, really, really big numbers. They're also used to write really, really small numbers. Okay? So you still have to move the decimal to form a number between 1 and 10. That does not change. All right? But in this case, instead of moving to the left, we're now moving to the right. And in order to tell us which way we're moving, we have to use a negative exponent. All right, so in this case, we have this big, really tiny number. We swooped it over to get the beginning number, 1.73. We multiplied by 10 to we moved it 6 places to the right, so it's the negative 6th power. All right. All right, so for example, this particular number, in this case, we would have 5.02 as my number. That's between 1 and 10. Multiply it by 10 to the 1, 2, 3, 4, 5, 6, 7. In this case, because I'm going to the right, it's negative 7. Let's check my answer. You're correct. All right, negative 7. All right, now, what if we want to go the other way? Oftentimes, we need to take these really, this scientific notation and turn it into the really, really, really small or really, really big number, okay? In this case, we're just working backwards. So write in standard form. The positive exponent will make the number get bigger. Right away, we can tell it's going to get bigger. And we start from the decimal point that's in the scientific notation. Okay, so in this case, we're going to move it 6 times. 1, 2, 3, 4, 5, 6. And my ending number is 3,780,000. All right, we can do the exact same idea working the opposite way. The number in this case is telling us that it is getting smaller because it's negative. So I take my 1.0654 and I move it 7 places, because that's how many it's telling me to do, to the left to make my number really small. All right, and then I just add a bunch of zeros in here. In this case, we're adding 6 zeros. So then my number is going to be that really, really, really tiny number, okay? All right. The last thing we're going to do today is talk about ordering these numbers. Ordering numbers in scientific notation is not that difficult. You basically just need to look at the number in front and then look at the exponents next. All right, so first we want to make sure that we fix any fakers. They will do this to you when you're working with really in any textbook or on any worksheet. They're going to try and fake you out. So make sure that all of these are in fact in scientific notation, that none of these numbers are bigger than 10, okay, or smaller than 1. They will try and do that to you. All right, so in this case, we don't have any fakers, so we're pretty safe, okay? The first thing you want to do is find out, okay, which are my really, really small numbers and which are my really, really big numbers. Well, if you look in our group here, we have 4 numbers in scientific notation. We only have 1 that's negative, which means that it's going to be the really tiny number, okay? Because the negative exponent gives it away. Now I have these 3 numbers. All right, and these 3 numbers, we can look at the exponent first and think, okay, well, we have 3, 4, and 6. Okay, but before we think we're done, we need to look at the beginning, okay? If, for example, you have 2 numbers that have the same exponent, like 3 and 3, okay, you would need to make sure that you check to see that your numbers are in fact bigger than each other. So in this case, we're fairly safe because really there is no need to look at the front. We can just look at the exponents and we'll find that we are in fact correct. Okay, so if you could please check for any fakers. Hint, hint, I see one. All right, list these in order from least to greatest. All right. All right, so I think I have given you a ton of information about scientific notation with a couple problems that you need to do in your WISC tonight. I think you're good. Um, Otherwise, if you do have any questions, please bring them to class tomorrow. Otherwise, have a good evening and start thinking about getting excited about scientific notation and exponents. All right, thanks, guys.